So today we are starting DSA. So the first topic we are going to discuss is algorithm. So the purpose of algorithm is finding a solution is not enough. Human realize the real challenge is finding a good efficient solution. So that's why algorithm comes to play. Librarian analogy. If a student asks a librarian to find Harry Potter among 1 lakh books, checking every book one by one works, but it is incredibly slow. Organizing the books alphabetically to jump straight to it. The H section solves the same problem but is significantly faster. This realization is how algorithms are born. So basically, people realize that finding a solution is not enough. We have to find good solution. For example, if there are 1 lakh books in a library, checking each book one by one is not a good solution. We should instead divide it into sections and then find a book. That's a better solution, and that's how algorithm comes into play. Programming defined. Programming is not just writing syntax like "see out hello world." It is an act of designing a sequence of steps to solve a problem efficiently, which is the exact definition of an algorithm. And it means that programming is not equal to writing code. Programming is equal to finding efficient solution. That is programming is. Historical context. Algorithm existing long before computers. Ancient merchants created step-by-step procedures to calculate profit, and Asian mathematicians developed systematic methods for large numbers. Around 300 BC, Euclid created an algorithm to find greatest common divisor. For example, to find GCD, leaves remainder 0. The answer is 6. We will still use the same algorithm over 2000 years later. Computers do not invent algorithms, they simply execute these human made steps much faster. So basically, computers are fast but dumb. To make them smart, we use algorithm to tell them what they have to do, and they perform it incredibly fast. They are loyal, like they follow what we say, but we had to give instructions carefully. So we had to define our algorithm as good as possible, then the result will be as good as possible. First principle and computational thinking. Every computational program, from finding a simple sum to Google search or YouTube recommendation, relies on universal three steps to structure: input, process, and output. So basically, computational thinking. This means solving problem in a way a computer can execute using pure logic with absolutely no intuitions or assumptions. Humans versus computer approach. If asked to find the tallest student in a class, a human simply looks around and spots them. A computer must start with the first student, compare them to the second, give the larger height, compare it to the third, and so on, step by step. The mental model and internal mechanics. The robot analogy. Imagine a computer as an extremely obedient but extremely stupid robot. If you tell it to make tea, it will ask what tea is, where the kitchen is, which cup to use, and which spoon. The golden rule. Never assume the computer knows anything. You must specify every single step. Inside the memory, if you code int a is equal to 5, int b is equal to 7, int sum is equal to a plus b. Thus, computer stores these at specific memory addresses. Example: address 1000 holds 5, address 104 holds 7, address 1008 holds 12. The CPU reads 5, 7, adds them, and stores 12. A computer is merely performing millions of these tiny operations. Example of algorithms in practice. To find the largest number between 10 and 20, a computer compares them. If 10 is greater than 20, output 10, else output 20. Intermediate. To find the largest number among 3, 2, 7, and 4, compare sets the current max to 3, then compares it to 7, max becomes 7, compares to 2, max stays 7, compares to 9, max becomes 9, and compares to 4, max stays 9. Advanced. YouTube takes input like watch history, like location and age, process, then thought a recommendation algorithm, and output a personalized feed. Every major tech company is essentially an algorithm company. Mistakes debugging and interview. Mistake. Beginners wrongly think coding equals programming. Write code before understanding the problem. Ignore input outputs, memorize solution, or jump directly to lead code without fundamental knowledge. Debugging. If int a is equal to 5, int b is equal to 7, C out a minus b, output minus 2 instead of the expected 12. In the engineer debug by understanding the expected output, checking all calculation and locating the wrong operation, finding a minus b instead of a plus. Interviews. Interviews do not just evaluate code, they evaluate problem understanding, logical thinking, communication, optimization, and the ability to analyze efficiency. Active recall. You must be able to answer what is an algorithm, why were they invented, what are the 3 stages of a problem, why does a computer need explicit instruction. Next, let's come to the CPU, RAM, and the warehouse analogy. A computer is like a giant warehouse filled with millions of boxes, where each box has an address, example box 1000, and a value stored inside, example 5. A worker reads values from boxes, performs calculation, and stores the result back. CPU, responsible for reading instruction, making decisions, and performing calculation. RAM, responsible for holding variable data and the programmer's program system. Variables are not boxes. Variables are actually just human readable names for memory location, where you declare int is equal to 18. The computer reserves memory, stores 18, and remembers the location, example address 1000. Memory addresses, because an integer int usually takes up to 4 bytes of memory. The next available free address for a new memory would be 1004. Different data type take up different space. Carry is usually 1 byte and double is 8 byte. When executing int c is equal to a plus b, where a is equal to 5 and b is equal to 7, the CPU does not natively see the math equation. It executes microscopic instruction: load the value from address 1000, load the value from address 1004, add them, and store the result in address 1008. The cycle. This is the heartbeat of every CPU, happening billions of instructions of times per second. Fetch, decode, execute. Fetch, get the instruction. Decode, understand what the instruction require. Execute, perform the operation. Mistake. Beginner falsely think variables are physical boxes. Believe the CPU stores data permanently. RAM does this, or thinks code executes all at once rather than instruction by instruction. Debugging. If a is equal to 5, b is equal to 10, a is equal to b is executed. Printing a result in 10, not 5. Tracing the memory line by line reveals that the assignment operation changes the value stored at A's memory location. If the interview asks what could happen, a variable is declared, or the correct answer is memory is allocated. A value is stored, and the variable means refer to that memory location. Memory is crucial because algorithms are judged by time and space efficiency. That is it for today.